Hi, my name is Yurchak, and today I will talk about in-browser data analytics using Pyodide and OfficeJS projects, and the use case I will discuss is the MicroBJ company. So if you look at the general trends in the industry that we currently see, we have essentially an increasing importance of analytics and decision support tools to actually make decisions. We have a convergence towards decentralized ecosystems where we have different systems that need to communicate in different ways. And generally, the human-machine interaction goes through either interactive dashboards or, for engineers, as was previously mentioned by Klaus, with notebooks. So if you look at the like a classical architecture for notebook-like model with, for instance, Jupyter is a famous one. We have a user that interacts with the browser that has some UI, and then the browser talks to the server that like sends a request through to the kernel, which actually does the computation, and the kernel is the one communicating, like fetching the data, making calculations, etc. And then as our number of users grow, what we'll have to do is we have to do some load balancing on the server, etc. So the complexity of the overall system grows. In the Pyodide model, what we have is essentially we try to run the kernel in the browser. So we use web technology, in particular WebAssembly, to make to run computations in the browser, and then you essentially can just directly communicate with like your data store, and everything happens on the client side. So the advantage of that is that obviously as we scale, well, it just scales automatically. You just have to distribute static files essentially. So if you take again the Jupyter-like model, in locally what you have to do if you want to run some data science application, you have to, for instance, install Conda Jupyter, then some project-specific dependencies. If it's in server, you have to say deploy a container or use some other technologies. Well, in this case, you would just essentially just deploy a static file to a web server, and then you just open it with the browser. So it's a fairly recent technology, so it's still not fully mature for the like production systems, but like that's the objective long term. Pyodide is essentially the plugin for this Pyodide project. So it's the Python plugin, meaning that we can actually build the Python interpreter in WebAssembly. And once we build the Python interpreter, we can essentially run any Python code with that interpreter inside that environment. So so it's a project run led by Mozilla, and that I have contributed to in the last few months. And essentially, the goal is to build an ecosystem of for scientific computing that would run in the browser using Python. So there were earlier projects, for instance, PyPy.js. So that one took the PyPy version of Python and then tried to compile it to ism.js, so which also runs in JavaScript, but essentially it was an earlier iteration because it's a bit slower and takes more. The packages are larger than for WebAssembly. So if we look at the supported packages currently, what was initially added was essentially the interpreter, which is the main part. So we have the CPython interpreter, and then were added NumPy, Pandas, Matplotlib. So essentially, when you say added, what it means is by default you can run any Python script, right? Because you have the interpreter. But then all these packages, because they deal with scientific computing, they actually have a lot of C extensions. So you actually need to build the C extensions. And there is the mscripting project that allows you to do that. And then in the part I have contributed to was to essentially add SciPy. So SciPy is the main like linear algebra and like scientific computing library for Python, like which is in the one of the base libraries that other packages depend on. And here the difficulty is that SciPy essentially has parts in Fortran, and then it also needs the BLAST/LAPACK libraries, which are the linear algebra libraries developed in the 80s maybe. And so essentially, because currently there is no Fortran compiler that works reliably for WebAssembly, so what we have to do is to use the versions that are converted to C. So there's a tool they called F2C, which converts Fortran to C, but then it's not perfect, it has limitations. And so that's why These packages have been ported, but they're still a bit experimental because they're not fully like ported, because there's still some parts that are like a bit more work. But the end goal is to have this like core packages on the Python ecosystem working. It means that you can just go to a website, open a notebook, it will just download static files, and you will have a full Python environment that you can use. And I think the vision is even a bit more broader for the Pyodide project, is that essentially what they would like to do is to have some language interoperability between, say, Python, JavaScript, and then other languages. So the idea is that you can, if you do some calculation, say in Python, your result is some array. Basically, you would like to use that array without doing memory copies in other languages. So, for instance, I think there is some support for those four, and for instance, Rust is also something that's planned. Rust works really well with the assembly because it's also developed by Mozilla, so it has like one of its goals is to really have nice, smooth experience. And for instance, R could potentially work, but there's still issues with Fortran. And then in the part, so the development I did on Pyodide were funded by Nexedi, and that were looking to apply this technology into real business use cases. And so to start that, Nexedi integrated essentially Pyodide into the OfficeJS App Store, which is a app store, HTML5 app productivity app store. And what it allows to do is to essentially, it allows you to use a Pyodide notebook, either online or offline, to use some to use different storage backends such as Dropbox, WebDAV, ERP5, thanks to the GIO library, and you can also embed it into different business applications. So, so for instance, if we take the use case where it was applied in practice, it's a MicroBJ company, which is a Chinese company. And the goal was to provide an easy-to-deploy business intelligence tool that would communicate with ERP5, and that would be browser-based. So the goal is to do inventory reporting, base sales reporting, and inventory provision. And the constraint is that, as was earlier mentioned, China network has specific constraints, such as that one cannot use WebSockets or WebRTC, and that clouding is much more expensive. Cloud is much more expensive than in Europe. And so, in that use case, running this business intelligence tools in the browser is actually a much preferable solution. So the development, just to mention, so I mentioned a few people, but more people contributed to both sides, of course. And so there's on the side for the Pyodide projects was mostly led by Mozilla, and some work funded by Nexedi, and the OfficeJS integration was done by Nexedi. Well, that's it. I think I'm done. I can maybe show a demo since we have some time.
Maybe a quick question.
Yeah.
So you actually upload the data set containing the data to the clients?
No. So you query the data you need. You don't upload everything, of course. Yeah. So you have some backend system that allows you to query the data, such as ERP5 or like any other storage, basically. If there's any other questions, don't hesitate as well. So also I forgot to mention, but this actually requires you to have a fairly recent browser. So It works really well in Firefox because there is obviously more communication with like people from Firefox. But like technically, it should work in most major browsers. But currently, it's much faster and it's actually more reliably working in Firefox. So, for instance, here's an example. So here we have a Pyodide notebook. As a Jupyter notebook, it's essentially the same idea. You can have some text. Here you will say, okay, we'll load Pyodide, which is just a JS file. But again, this could be some other language plugin, so it doesn't necessarily have to be Python. And then we can, for instance, run. Okay, it's still initializing, and I hope it will work. Yeah. Okay. So and here we have a working Python environment here that we can use for something. So we can do plots, we can do scientific computing, interacting with some remote server, etc. So what's interesting here as well is that you see this is we were able to actually run it on this network. And when previously I tried to load my presentation, it didn't load because it was not on a non-standard port. So if you try to like say if you have to interact on some custom communication system, it will be a problem in a number of use cases. Well, here we don't have that issue. And then, well, essentially you can do anything you can do in Python. You can also communicate. Essentially, you can pass information between JavaScript and Python easily. So you can call JavaScript functions from Python and vice versa. So that's pretty much it. I don't know if you have questions.
I'm concerned about the performance of this.
Yes. So I mean, it depends the performance for which parts. So basically, WebAssembly is near native speed in terms of like if you take C code, you compile it to WebAssembly, it's going to run reasonably fast. And a lot of this in Python is actually C code, right? So the CPython interpreter and the NumPy, SciPy, etc. But so the limitation, of course, you have some overhead. I mean, of course. Then you don't have, there's some parts that are still not implemented that they plan to do. So for instance, you don't have threads currently. You cannot start processes. You don't have SSC or AVX speed like vectorization. So of course there are limitations, and also like I didn't mention it, but this is a 32-bit architecture. So it means that you have some limits inherent to that. But I mean, in the future they do plan to extend that, to improve on that, and I think those things will be resolved eventually.
The main concern that I see is that JavaScript inherently is single-threaded.
No, but there is I mean, it's so it's not really. You don't really run that in JavaScript. You run that in WebAssembly, which is implemented in the browser as a separate thing from the Java. Like it's part of the JavaScript engine if you want, but it's not like it's not really limited by what you have in JavaScript. So I think one of the goals to develop this kind of approaches was exactly to overcome the limitations of JavaScript.
Right, but you still have to start from JavaScript to get into the.
Yeah. Sure.
I'll say a word while
Sure.
we finance this.
Yep.
So before we finance, we measured the speed. Python in a browser is 20 times slower. NumPy in a browser is about same speed. So if you do data science in Python in a browser, you have a combination of 20 times slower and same speed, which in average will be half. But what is great is that if we distribute this to 1,000 people, we have 1,000 people running at half speed, which is much better than 1,000 people on a Python runtime, which is single-threaded. So compared to running Python on a server, where the Python, let's say, driver is single-threaded, and the backend for array calculation is multi-threaded, we actually have a much more multi-threaded system because every user is running his own environment and it costs us nothing. And also it brings this type of assistant tool to any users in a factory or any users in any factory in the world of a given company instantly without installing any server, without doing anything. So it's really fantastic because it's like suddenly AI and machine learning can be deployed in one click to all employees of a company without scalability issues. So
the only problem I see is that you still have the overhead of the browser in the client's machine. So you're paying a bit for having to have the browser open. I imagine that most users don't really care about this at all.
They don't. For simple things, they don't care. So we pre-process the data on server side to make it fit into a size that is suitable for the browser. Then it is the last part of interactive visualization and processing that runs in the browser. When salespeople dig into sales, when engineers dig into part of the signals and want to change things in real time, all that part, when running in the browser, actually scales much better than on server side.
So do you also pre-process parts of the data set for specific user groups?
For sure.
Is there any plan to support
Sorry?
.NET Core?
To
support .NET Core? .NET languages?
Not for us. Is there any plan to support .NET? Maybe somebody else will do, but not Nexedi. Okay, next is...
May I ask why it's not planned to support .NET Core? Because it's like also open source and Microsoft put it in Linux area. And it's more like enterprise, will be more enterprise based.
We are not interested.
I think Nexedi is going to fund, and there is also the pilot project that might be like, if you contributed, then you might get in.
So Roman is saying, please feel free to contribute to someone like Roma who is interested in .NET. Then you will get it. So actually, we really used on this public money from French government that goes to Nexedi, then is used to pay Roman, and after a couple of months, which is very fast, we suddenly get machine learning in a browser. So it was very efficient use of public money.
Actually, for this, at least for me, there's also a reason why I think it's so great, because then we don't have to integrate stuff like .NET with our own systems, because everyone is free to use, like if it's finance editor, whatever programming language or whatever framework you want, and it doesn't need to be really integrated with the server. Then .NET doesn't need to be maintained on the server. Actually, you can use it. So for us, it's also as an open source communicate to address industries which need to basically probably learn. Because until now, we can read the because we make it.